Okay, question number 4. A circular coil of n turns and radius r is rotated at constant frequency f, a uniform magnetic field. Magnetic flux linkage of the coil is given by the flux is equal to n pi r square b cos 2 pi ft. So this is the flux linkage. So number 1, deduce the expression of EMF induced in the coil. So now let's say you have this is a magnetic, you have a magnetic bar, right, and you have a coil between the two magnetic bar here. Say you have the coil, and the coil now is rotate, right? Let's say that from up and down or rotates. And radius, this is this coil, circular coil, right? The radius here, this is circular coil. The radius is given by the r, radius r at r. And so now if you have the magnet here, so you have a magnetic field, right, B. So as you know, when the coil rotates, coil got the magnetic field B and induce EMF. So EMF induced is the rate change of flux. But the question gives you the value of the flux linkage here is n pi r square b cos 2 pi t. So now from the flux linkage to the E here, or EMF, you use the d flux dt. So meaning the now you have a flux here is a n pi r square b cos 2 pi ft, and now you have a dt. So now induced EMF is a differentiation of the dt. So now you have a induced E is equal to, so at for the differentiation at the time t, so now you have a 2, this is mathematic, right, 2ft and pi r square b. So differentiation of course is a sine or minus sine, right, 2 pi ft, right. So now you have a the value of the, yeah, you can compare the answer given by the question is n. So this is n. Pi, you have 2 pi, yes, pi and r square, so we have a r square, and you have a frequency, so we have a frequency, and we have the sign. So you can use a positive or negative, right? The answer must use a negative because the differentiation for the cos is negative sign. And 2 pi f, sine 2 pi f, sorry, 2 pi ft. So this is the answer or induced EMF, right? So now the next question is if n is equal to 100 turns, r is equal to 5 cm, magnetic field strength is 1 Tesla, and the frequency 50 Hz, calculate the maximum EMF generated. So how you can calculate the EMF? So this is the equation of EMF. So to calculate the maximum EMF, right, this is question number 2, right? So what happened to the sign? So sign must have maximum. So sign maximum is equal to 1. Now you can use the value is given by the question, n is equal to 100 turns, frequency is equal to 50 Hertz. Right, another here is radius r is 5 cm, convert to the meter is 5 exponent minus 2, and the B is, so it's B, yeah, 1 Tesla. Right, so now you can use the calculator to calculate the maximum E is equal to, this is number 2, right? Maximum EMF is equal to 246.74 volt, right? And number 3, a rotating coil generate maximum EMF 500 volt. So this is maximum EMF 500 volt. Yeah, this is C, right? This is E. So now E here is a 500 volt. This is the question number 3, the third situation here. And calculate the number of turns. So what is the value of the N if radius is 5 cm? So the same, so convert to the meter is 5 exponent minus 2. So remember, when the rotate generate maximum, still the sign is equal to 1, because maximum sign is equal to 1. Value of the sign must is equal to 1. So now you can use the value here, because the sign is maximum. So I just write here. So now you have a 2 pi f is number of turn, and this is pi, and this is radius square, and this is B, right? So now this is equal to maximum EMF is equal to 500, right? So the question asks you what is the value of the number of turn N. So now you can find the value of the N here. So use a frequency is equal to same frequency, right? 50 Hertz. This is 50, and the B is equal to 1, and R is equal to 5 exponent minus 2, and this is 2 pi and 2 pi. You can use the calculator to calculate the value of N. So the N, can use the calculator, is equal to 203 turns, right? Number B